your TED Talk, which of course has been viewed by millions of people now, there was a really interesting slide towards the end where I very much resonate with this idea. What's the root cause of multiple diseases? Can we, address the root cause, and then we're automatically going to take care of multiple different downstream consequences? And that was a very powerful slide showing that when angiogenesis is working well or when it's not working well, what can happen in the body. Could you just talk us through that lens, angiogenesis? Because I think that's really interesting. And then you also mentioned cancer and blood supply. And again, could you just talk to us about cancer and how it can only grow to a certain size unless it gets its own blood supply as well, please?
Yeah, sure. Our circulation is these blood vessels, this network, and the blood is really the vehicle that carries oxygen and nutrients and everything else that our cells need to survive. So when we have the right amount, all of our organs are functioning properly. Sometimes we need a few extra blood vessels. So if you're working out and trying to build your muscles, when your muscles get bigger, it requires more blood vessels, bigger blood supply, no problem. Your angiogenesis system can actually supply and help to grow more of those blood vessels, but they keep it in proper volume. So not too many, not too few blood vessels. Very important principle of angiogenesis. That's health. We have good circulation. Now, here's what happens in disease. When you don't have enough blood vessels, what are some of the typical diseases that occur when you don't have enough blood flow? Well, one of the things is after a heart attack, if you cannot grow enough blood vessels, parts of your heart will get weaker. You can get heart failure, and a heart attack can actually be even fatal if you have inadequate blood vessels to try to bypass any temporary blockage. Same thing as a stroke. We know after there's a stroke, sometimes a clot gets sent to the brain and results in that type of stroke. Your angiogenesis defense system is scrambled to be able to immediately generate tiny little bypass vessels, get around that blockage to save the brain beyond the blockage. If you can't get enough blood vessels growing in that situation, parts of your brain die, and you wind up being paralyzed or having deficits after a stroke. In diabetes, many people with diabetes lose their legs. They have their legs amputated, mostly because they have problems healing wounds on their feet. Yeah. Now, the reason is because their nerves actually they go numb. Their nerves die back, diabetic neuropathy. And the reason that the nerves die back is because there's inadequate blood vessels feeding those nerves. So now in diabetes, some of those nerves in your feet and even your fingertips actually don't have enough of a blood supply. They die. When the nerves die, you can't feel when you step on a pebble and you create a little hole. That hole gets infected. That wound now also won't heal because it doesn't have enough blood vessels. That's an example of inadequate angiogenesis and cause a problem. And so now medical treatments actually have been designed to actually try to stimulate more blood vessels, to coax more vessels in where they're needed, but foods can also help do it as well. On the flip side, when you have too many blood vessels, and this is where cancer comes into play, it turns out that we all have cancer in our body. I mean, everyone fears cancer. The word actually, causes a shiver to run down most people's spine. Yeah. Everyone knows somebody who's been touched by cancer. And I would say most people know somebody who's died of cancer, actually. And so this is actually one of the most fearsome diseases, but yet biologically, we are actually all forming cancers in our body all the time, because all it takes for our 40 trillion cells to do is to make those little mistakes. Remember, I told you 10,000 mistakes are fixed every day. A few of those sneaking through will turn into a microscopic tumor, microscopic cancer. And this is called cancer without disease because a tiny little mutant cancer can grow up to the size of the tip of a ballpoint pen, and then it's frozen like a pimple. Can't go any bigger because it doesn't have a blood supply. No oxygen, no food, nothing to feed it. And so those little microscopic cancers sit there until until another one of our defense systems, our immune system, wings by like a cop on a beat and sees this abnormal cell sitting on that street corner in a good neighborhood, and then says, "Get in the car, we're taking you away." And so our immune system destroys these microscopic cancers. But some microscopic cancers are able to hijack our body's regular angiogenesis defense system and selfishly grow blood vessels to feed themselves. Now, I worked in a lab studying angiogenesis, and we discovered that once an avascular or bloodless cancer is able to get vessels to touch it, the moment that touches it, the cancer can grow 16,000 times in 2 weeks. So literally, angiogenesis out of control is a trigger, an explosive trigger for tumor growth. And in fact, we know that if you can cut off the blood supply or prevent tumors from growing their blood supply, you can actually keep these cancers harmless for long periods of time. And so this is what foods are able to do. Foods that inhibit angiogenesis, they won't stop the good blood vessels from growing, because good blood vessels are actually solidly locked into your body. Your defense system ensures you're not going to get rid of your good blood vessels with food, but those extra blood vessels tend to be fragile, and those are the ones that the foods that we eat, and then if necessary, drugs that we can prescribe can really just kind of shear those extra vessels away.
Yeah, this whole sort of field of angiogenesis and blood vessels, I think, is going to be fascinating for people, because I think many people, everyone's aware that they've got blood vessels inside them. I think a lot of people will think, yeah, I sort of learned this in biology at school, that there's the heart and the blood vessels, it pumps oxygen around the body. That's how oxygen gets to all my muscles and organs. But potentially it kind of ends there. Like, it doesn't go beyond that. And what I love about that explanation is when angiogenesis is not working well, we're not able to make new blood vessels where we need to, it can cause a whole multitude of different diseases. But also when it's kind of out of control or gets to these cancer cells, too much angiogenesis can cause problems. And therefore the question for me, Dr. Lee, is, if angiogenesis sits at the heart of multiple different conditions, so we can look at it as a root cause, we also say similar things about chronic unresolved inflammation, don't we? We talk about inflammation being a root cause of lots of these chronic diseases. So can you speak a little bit about the relationship between inflammation and angiogenesis? Because it strikes me that they can't be separate. They probably sit side by side together in most cases.
Yeah, no, it's such a great question. I actually worked on research exactly looking at that interrelationship. Wow. So we know, well, let's take a look at just sort of something everybody recognizes, and to show how inflammation and blood vessel growth go hand in hand. If you are in the kitchen and you accidentally cut you're cutting a piece of fruit and you accidentally cut your finger or cut your hand, what's going to happen? It's going to bleed. All right. Now, so you're going to stop the bleeding. Then a few minutes later, you look at the cut. What's going to happen? It's swollen. It's puffy. It's red, because inflammation's actually gotten there. Your immune defenses have sent these inflammatory cells. These are the kind of super soldiers from our immune system that go there to kind of clean up and prevent any bacteria from rushing into that site. And then shortly thereafter, within a day or so, new blood vessels start growing, because the inflammatory cells, the cells from your immune system, started to release some signals to say, hey, you know what? We've cleaned up. It's time to reset the table. And so now blood vessels actually start to grow into it. So inflammation sends the signals for wound healing, for blood vessels to grow. By the same token, inflammation then goes away, which is why our wounds don't stay puffy the whole time. The puffy and redness goes away. The blood vessels grow, you get a scab, and before long, you're back to normal. And that's because both inflammation is turned off, like that's that car volume of the car radio, and also angiogenesis, once you get enough, it stops. And so this is getting back to that set point. Now, what happens when you actually have chronic anything? Usually it's not a good result. So inflammation being really good, a little bit is really good. So, I think a lot of people misunderstand, like, I want to get rid of all the inflammation in my body. No, you don't, because you want the ability of your body to be able to mount small amounts of inflammation when needed for a short period of time and then to go away. All right. That's you want that. That's life saving. But what you don't want is for that inflammation to get there and the volume to keep turning up, 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 or that it never gets turned back down. That's chronic inflammation, and that's abnormal. So your body, this whole idea of turning up and then turning down the volume for inflammation, if you can't turn it down, the inflammation continues to smolder in your body. An example I've given is sort of like for anybody who's listening who's enjoyed going camping.
Yeah.
You go into woods, you set up a tent, it gets cold at night. What do? You build a campfire. And that's like a little bit of inflammation, gives you warmth that serves its purpose. And, when it's time to go to bed, you either let it burn down and you just, make sure that it's all walled off and you're fine. But that fire, if it doesn't burn down, but actually spills out and catches the forest on fire, now you actually got a problem, because now this thing is going out of control. And diseases with chronic inflammation, like lupus, like rheumatoid arthritis, like diabetes, frankly, you wind up actually having this chronic inflammatory state that starts to provoke all kinds of other things. And remember, we talked about tumors and angiogenesis. Well, if a tumor is kind of like a wound, it can hijack blood vessels, and you got inflammation, and now the cancer itself causes some inflammation, you're just making it a hell of a lot easier for that tumor to get a blood supply, which means that the cancer is more likely to grow. And in fact, we do see this in patients who are actually chronically inflamed. We know that inflammation is one of those hallmarks for people who develop cancer.